This is a real human brain, and these are multiple nerves that would innervate or control the muscles of the upper limb. Now, why would I be showing you a brain and nerves during a video about hydration, water, and electrolytes? Well, water and electrolytes are actually quite relevant to how your brain, nerves, and even muscles work. But how much water and electrolytes do we really need on a daily basis? And what is the best strategy for replenishing water and electrolytes? We are definitely going to answer these questions, but let me first go back to the brain and nerves so that we can start with one of the important reasons as to why you actually even need water and electrolytes. Your brain is made up of about 100 billion nerve cells called neurons, and your nerves are primarily just bundles of neurons wrapped in connective tissue. And what is remarkable is that these neurons send electrical signals. But how in the world does your body generate an electrical signal? It's not like we plug ourselves into an outlet and charge ourselves up. That would obviously be bad. But the story of our ability to generate electrical signals and how this relates to hydration starts with some quick info about the periodic table. Now, many of you have probably seen the periodic table, which shows you the elements. Now, some of these are extremely important to the functioning of the human body. There's some obvious ones like oxygen, carbon, and hydrogen, but also things like sodium, potassium, chlorine, magnesium, and calcium, to name a few. Now, for those of you that are terrified or just hate chemistry, hang with me for just a second here, because this is really cool how this relates to water, electrolytes, and your overall hydration. All of these elements listed on the periodic table are listed in their purest form in their neutral state. So for example, if you had an atom of sodium in a neutral state, it would have the same number of protons, which have a positive charge, and the same number of electrons, which have a negative charge. The negatives and positives would cancel each other out, and again, you'd have a neutral atom of sodium. But in nature, many of these atoms don't exist in a neutral state. They exist with a charge. And an atom with a charge is referred to as an ion. And this is extremely important for our story on hydration and electrolytes. Things like sodium and potassium, for example, lose an electron because they're more stable this way, and therefore mostly exist in nature as a positive ion. Magnesium and calcium are also positive ions, where something like chlorine gains an electron and is a negative ion. And you may already know this, but sodium and chloride love to get together with their positive and negative charges to form sodium chloride, which we all know as table salt. But again, what does all this have to do with water and electrolytes? Well, when ions, like sodium and potassium, are tossed or placed in water, we call these ions electrolytes. And this is because an ion in water has the ability to conduct an electrical current in water. And luckily, we are made up of a lot of water. But this gives us the answer to how our neurons can generate electrical signals. Our neurons take electrolytes and pump some of them to the outside of the cell membrane of the neuron, while pumping other electrolytes to the inside of the neuron. And this creates a charge difference from the outside of the neuron compared to the inside, and therefore gives the neuron an ability to send the electrical signal. And this signal is known as an action potential. So you can see how important water and electrolytes are just for the proper functioning of your nervous system, and even for muscle contractions, because muscles will use electrolytes in a very similar way to create action potentials for muscle contractions. And this process works beautifully when we have the proper balance of water and electrolytes. But what happens when we are not in balance with our water and electrolytes? Well, for us to best understand that point, we'll want to cover some of the other functions of water and electrolytes and some of the things that cause us to lose these substances. And then, of course, that will lead us into some of the best strategies for replenishing our water and electrolytes. So let's quickly talk about some other important reasons why we need water and electrolytes, and then we can talk about what happens when we get out of water balance, and then, of course, rehydration strategies. Water is the universal solvent, meaning substances dissolve in water, and water provides a medium in which many of the body's chemical reactions take place and is therefore critical for these physiological processes. Water also acts as a transport medium, as it's a major component of the blood, and is also essential for thermal regulation, maintaining that proper temperature throughout the body. And this will be especially important when we talk about cooling off the body through sweat in just a minute. Water also helps to provide moisture for certain tissues and structures, and even provides protection or a form of cushioning as cerebral spinal fluid for the brain and as fluid found in cartilage and joints. Electrolytes not only allow our neurons to function properly, but they also affect how and where water is distributed throughout the body. As water tends to flow towards areas or spaces in the body where there are greater amounts of solutes or electrolytes. And there are pretty much three main places where you find water throughout the body. You find it in the intravascular space, which is to say inside the blood vessels as plasma, and this accounts for about 7% of the total body water. You also find it in the intracellular space, which would be inside the cells, and this accounts for the largest amount of body water at about 66%. And you also find it in the interstitial space, which is the area between the blood vessels and the cells, which accounts for about 26% of total body water. And how water is distributed throughout the body is really helpful to help you understand certain scenarios, like with water distribution issues or with water and electrolyte imbalances. Like if you were to have too much fluid in the interstitial space, that space between the blood vessels and the cells, this could result in swelling or edema. Or if you had too much fluid in the intravascular space, like the space in the blood vessels, this could create increases in your blood pressure, and why sometimes you hear about this relationship between high blood pressure and high salt diets. And what about the opposite end of this? If you had too little fluid in that intravascular space, which can happen with extreme fluid loss through like extreme sweating through exercise, this would result in hypovolemia, making it more difficult for your cardiovascular system to deliver blood to the tissues throughout the body, and if it gets bad enough, could lead to hypovolemic shock. And let's even go with another extreme case. If you drink way too much water, which we'll talk about a case where this occurred with a marathon runner, this could cause too much fluid to enter the cells, that intracellular space, and cause the cells, like the neurons, to swell and therefore would not function properly, and in extreme cases could even result in death.